Texas Instrument Innovative Challenge has given an international platform to many students around the world to prove their analog design capabilities. As a part of Texas Instrument Innovative Challenge India Analog Design Contest 2014, we have got the opportunity to implement our idea titled Design and Development of Smart Geyser. It is an era in which automation is at its boom. We human beings go for the path in which we can complete our work in minimum possible time with minimum possible expenditure. Also, the power efficiency comes to the mind when we develop the technology that we use for the daily purpose. Design and development of smart geyser is done keeping in mind all such factors. In the next video, we will demonstrate about the components used and the circuitry we have designed for the development of the system.
This wireless system consists of two sections, transmitting zone and receiving zone. Transmitting zone or the remote zone have the entire platform interfaced with at 16. This system mainly comprises of switching unit, a communication unit and a display unit. So the switching unit comprises of two sections. One is to control the temperature and second one is to monitor the level. Which is another switch to reset the entire system that will enable the controller from the sleep mode that helps in optimizing the battery power and maintain stability always. This entire system can be viewed by using a 16:2 LCD and entire system is powered by a supply unit which uses 7805 IC regulator. For communication systems or for communication unit I am using a 1197 Zigbee unit that is interfaced with the CC2500 controller which helps to maintain 802.11 protocol. The receiving zone consists of a Texas launchpad with MSP430Z2553 controller. This circuit is powered up with 7805 unit but that provides 5 volts power supply and a LM358 from Texas Instruments that convert 5 volts to 3.3 volts that will power up the processor. This system consists of a monitoring zone, communication zone and a display zone. A K-type thermocouple interfaced with MSP controller acts as a medium for temperature monitoring and a low cost resistive band is used to measure the water level. In communication zone, as we have seen in the transmitter side, a 1197 Zigbee model is being used and interfaced with the controller. A 20:4 LCD is used for the purpose of display. In the next video, we will be showing how this circuit works and how transmitting receiving is achieved and how our smart geyser is going to work. This is the entire receiving unit connected to the smart geyser. So for this one, here you can see K-type thermocouple interfaced with this one and this is a TIIC module that can trip the required voltage at required time and this is the communication zone which we are using a 1197 Zigbee module for Zigbee communication.
This is the inlet a tank that will act as an inlet. This is the inlet pipe going to the geyser. This is the prototype of the geyser that we are using and this is the receiving unit that have been explained earlier. Now we would like to explain the structural modification that we made in order to develop the required system.
See the heating element and these were the three different outlets. The inlet is at the base junction and here you can find the resistive band to identify the level. Based on the level identified by the resistive band, the respective outlet will be open. And here you can find the K-type thermocouple for monitoring temperature.
This is the inlet to the geyser and these are the three outlets for three different levels that act as an option to the user. To reduce the problem of opening the respective valve of the outlet chosen by the user, the valves are coupled with the motors that are controlled by the receiving unit.
In the transmitting side, the user has given a chance to provide the level that he requires along with the temperature. So here are the three switches placed on the transmitter side that he can define his own level, water level, that is 50%, 75% and 100% based on his requirement. And now on the temperature side, these are the four switches and he can define his own temperature of 70 degrees, 80 degrees, 90 degrees and 100 degrees. And at present I am selecting 50% of water level. So an acknowledgement is sent from transmitting side to the receiving side, and you can see that one on the receiving LCD panel. After selecting level, the user has to define the temperature that he wanna require. So here he has four options, that is 70, 80, 90 and 100. So for easy and convenience, I am selecting 70 degrees of temperature. So that acknowledgement is being sent from transmitter to receiver. After selecting these two, first the water level definition will give the acknowledgement and water will be filled up in the geyser, and then heating up starts.
Side view of the prototype of the geyser. The temperature of the water before heating was 18 degrees, and after waiting for the sufficient time period, it has now raised to 60 degrees with the level of 50% that is chosen by the user. After waiting for the sufficient time period, the level and temperature that are chosen by the user have been raised, level for the 50% and temperature for the 60 degree. It can be seen on the LCD. We would like to thank our mentor Mr. Rajesh Singh, who has always helped us out in each and every step. Also, we would like to mention the name of Mr. Ravi Kumar, Texas Instruments, who believed in our idea and gave us this wonderful opportunity.